Hello guys, this is Foolish Engineer and this time we are going to see a DC to DC converter that works as both constant current and constant voltage regulator, which is used for battery charging. So let's start. A CCCV DC to DC converter regulates both current and voltage as per the requirement of load. If you remember the Ohm's law, at any given resistive load, we can only control either current or voltage at a time. And another parameter is determined by the Ohm's law and the load. Well, this is simple math, we can't bend the rules. That means we can either give the priority to constant current, but output voltage changes, or we can supply constant voltage and let the current vary if there is any change in load. There are many applications where we can use a CCCV converter. For example, we can use this converter for LED driving. And one of the most popular applications for this is charging battery or supercapacitors. As we know, rechargeable batteries need to be charged with CCCV configuration in order to charge them quickly, safely, and efficiently. So these CCCV regulators make the right choice for battery charging. CCCV charging method is a hybrid approach which controls either output current or output voltage at a time. While charging the battery, first it uses CC charging, and when the voltage of the battery reaches up to required threshold, the charging process shifts to the CV charging method. This charging process is completed when the current flowing through the regulator is very small or the capacity of the battery is fully reached. Well, this CCCV charging method is very useful for charging the lithium-ion batteries. These are the same batteries which we use in electric vehicles or portable appliances which we use daily. Yeah, every single portable electronics thing, right from your electric toothbrush to laptop. Well, this CCCV method is quite tricky, but don't worry. We'll see very easy analogy where we can understand a battery charging method. Let's consider we have a coffee takeaway cup. It's a normal paper cup which we get from McDonald's or Starbucks. And we have a big reservoir of water supply. Now our task is to fill this cup with water. And the water can be fetched from this container using this tap. And we can control the flow of water by opening or closing this tap to fill this cup. Now, considering the limitation of the capacity of this cup, we will release the tap. The pressure of the water supply should be more. It should not be more. If the pressure is too high, then this poor weak paper cup might tear down due to this immense water flow. So the pressure should be limited. The water is being poured into the cup. When the cup is about to fill up, we decrease the water pressure by tightening the tap a little bit and wait for the cup to fill up fully. As soon as the cup is filled up with sufficient amount of water, we close the tap. Now, let's compare this analogy with CCCV battery charging method. Imagine the paper cup is a battery or cell, and the water reservoir is the reservoir of electrical energy. Filling up the cup with water is analogous to charging the battery. The tap of this water container is a battery charger, and the person who is controlling this tap is the charger controller. Now in the initial phase, the battery is charged with constant current just like we open the water tap. The charging current of this regulator should be limited just like we control the pressure of water. If we don't do so, the high supply current may damage the battery internally. Well, this depends upon the chemistry of the battery. When the battery is charged up to a certain value, the terminal voltage of the battery increases and the charge controller senses that change in voltage. This time it immediately shifts from constant current supply to constant voltage charging, which limits the supply of current to maintain constant voltage, just like we did in the analogy by tightening the water tap. Here the flow of water is just like the current flowing into the battery. Once the battery is fully charged, the charger turns off the charging. And that's how a CCCV regulator works as a battery charger. The charging time of the battery is decided by the constant current mode. The suitable current value provides a balance between charging performance and the battery's safety. If the current is too high or too low, it can cause negative effect to the battery. Well, I think you understood how this battery charging works. But now, let's see the detailed working of this battery charger with more technical terms and voltage current waveforms. Hope we are ready for this. Initially, when the charger is powered up and input voltage is provided, the charger measures the cell voltage. If the cell voltage is less than the pre-charge threshold, the charger understands the battery is deep discharged. In this case, if the juice of the battery is used too much, the battery voltage becomes very less. So for this, the charger enables trickle charging, in which it charges the battery with 10% of the full charging rate. That means if the charging rate of the battery is 2 ampere hour, then the trickle charging is done with 200 milliampere hour rate. This slow charging prevents the battery from being damaged from high surge currents. And this trickle charging continues up to the terminal voltage of the battery reaches to minimum charging voltage. In case of lithium-ion batteries, it is 2.8 volts or 3 volts. Also, it depends on the chemistry. If it doesn't reach this voltage level, that means the battery is possibly shorted or damaged. So, in this case, charging stops. But once the cell voltage crosses the pre-charge threshold, the charger will shift to 100% full charging rate. Now the charger charges the battery with CC mode. In this cycle, the cell voltage rises until it reaches the constant voltage threshold. For lithium-ion batteries, this voltage is around 4.2 volts or 4.242 volts. If the battery is charging with 1C rate, then it normally takes about 1 hour to reach this point from a fully discharged state. Well, if you don't know what is C rate of the battery, then please check out this video where we have explained all the basic parameters of a battery. At this point, the battery charged up to approximately 70 to 80%. Now the charger shifts to constant voltage mode. During this state, the current gradually decreases to maintain this constant voltage as the battery approaches to full charge state. Finally, charge current falls up to very low value. Well, the charger monitors this current flowing through the circuit. When the current drops to 10% of the full charging rate, this can be called as end of charge threshold for a battery. Normally it takes a considerable amount of time to reach this point. Once the charger reaches this state, the charger stops charging. Well, sometimes it happens where the battery voltage drops below the recharge threshold. This occurs if the load is connected to the battery or battery is kept idle for a long time. So if this happens, the charger starts the charging sequence again and begins a charging cycle and charges the battery. So this voltage threshold for lithium-ion battery is around 4.03 volts. Well, this process keeps the battery fully charged every time and prevents self-discharging. So, that's all about the battery charging and how a DC to DC converter adapts to these charging steps. Next time we'll see the control mechanism of CCCV converter and we'll see the simulation where we can simulate the load with different conditions to check the constant current and constant voltage mode. Till then, stay tuned. I hope you got something from this. If you haven't, you can watch the video again. Still, if you don't, you can ask your doubts in the comment box below. Hit the like button if you like this video, subscribe to my channel, and finally, thanks for watching.